Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 11.5, Inscribed Angles and Polygons. By the end of the lesson, you'll be able to use properties of inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords. We did an activity with this, but here's a picture to go with it. So you've got a circle. The vertex, which is like the elbow, is on the circle. And then these sides are chords. There's a chord, there's a chord. That is an inscribed angle. The intercepted arc is the arc that's in the interior of the inscribed angle. So the interior arc of the inscribed angle. So we'll draw this picture again. Here's our inscribed angle. The vertex is on. Here's the intercepted arc. It's the arc that's between the sides. Almost like if this were an alligator, it's eating the arc. That's the intercepted arc. Intercepted arc. And think of intercepted maybe like in football where one team gets the ball from the other, it cuts the other team off. Well, this side is cutting off the circle here, and this side is cutting off the circle here. This is the intercepted portion. Inscribed is when a polygon has all vertices on the circle. So you could draw a circle. You can make it as many sides as you want. Maybe we could do a 5-sided shape. So you put 5 vertices on the circle, connect them to make a pentagon. So this pentagon is inscribed because all the vertices are on the circle. Just like inscribed angle, but now we just turned it into a shape. Circumscribed is the circle around the inscribed polygon. So that's circle. And we did an activity where you had to measure this angle and compare it to this arc. And this angle and this arc are the same. And you should have got that it is half. So if you remember from before, we had the central angle is equal to the arc. Now the on angle is equal to half the arc. So we've got two different things going on now. And we're talking about these on angles, these inscribed angles today. So if you look at our first example, we're trying to find the measure of the angle or the intercepted arc. Well, notice this angle is on an inscribed angle, and this is the arc that it's chomping on, that it's intercepting. So we know our formula for on angles. On angle equals the arc divided by 2, or half the arc. So let's look here. On angle, well, that's angle M is what we're looking for. So M equals the arc. What arc is eating? It's eating 100 divided by 2. So M is equal to 50 degrees. Over here we also have an on angle, an inscribed angle. And it's chomping on, it's intercepting this arc right here. Well, we have on angle equals arc divided by 2. Well, our angle this time is 105. 105 equals arc. We don't know the arc. We can call it ZWX over 2. If you want, you can think of this like a proportion. 2 times 105. So ZWX measure of arc ZWX is equal to 210 degrees. So if you're trying to find the angle, you divide by 2. If you're trying to find the arc, you multiply by 2. So you're going to do these now. Here you're trying to find the angle. Here you're trying to find the angle. And here you're trying to find the arc. This is just like example 1. Now we've got a triangle inscribed. All the vertices are on the circle. If a triangle is inscribed in a circle, if a triangle inscribed in a circle is a right triangle, then the hypotenuse is the diameter. If one leg of a triangle inscribed in a circle is the diameter, then the triangle is a right triangle. Now I'm going to explain this to you. If this is a diameter, that means that over here is a semicircle, which is 180 degrees. And look at angle B. Angle B is opening up to 180, which means angle B is half of 180 because it's on. So if you ever see a diameter, the angle that opens up to the diameter is going to be 90. It's going to be half of 180. So let's do an example. So I see a diameter right here. And notice angle C is opening up to the diameter. It's opening up to 180 degrees. Since it's an on angle, we have to take half of 180. So that means x is 90. Put 90 there. Now we need to find y. Well, you know how many degrees in a triangle. You know that there's supposed to be 180 degrees in a triangle. And we already have 90, and we already have 50, which means we need 40 more degrees in our triangle. So x is equal to 90, y is equal to 40. All right, I want you to do this now. Notice lots of them they all have diameters. So ask yourself, which angle is opening up to the diameter? Is it x or y? And that's going to be the one that's 90 degrees. The angle that opens up to the diameter is 90 degrees. Now we have a quad in a circle. So we just had a triangle in a circle. Now we have a quadrilateral in a circle. If a quadrilateral can be inscribed in a circle, then its opposite angles are supplementary. If the opposite angles of a quad are supplementary, it can be inscribed in a circle. All right, I'm going to try to explain this to you. I'm going to use some colors. So it says opposite angles, remember supplementary means equals 180 together. So if you look at angle E is opening up to this arc right here. Angle E is opening up to that arc. Then I want you to look at its opposite angle, which is G. Angle G is opening up to that arc, this arc right here. So together, E and G are making the whole circle. But since they're on angles, they're inscribed, we have to do half. So together, E and G are half of the whole circle, which is 180. Same thing for D and F. Opposite angles equal 180 if a quad is in a circle. So this is for quads in circles. This is the rule. So let's practice. We learned that this is a quad in a circle, so opposite angles must be supplementary. Okay, so let's see, T is opposite of R or Z. So these two together have to equal 180. How many more degrees do I need? Well, R and T have to make 180. I already have 80 degrees, which means I need 100 more. And these are opposite angles, so they have to be supplementary because they're in a quad in a circle. So they have to make 180. Well, I already have 120 degrees. How many degrees do I need? I need 60 more. In example 3, what should the sum of the measures of the interior angles of RSTU be? Well, RSTU is a quad, and all quads have 360 degrees. So let's check if we did this right. We're going to add all of these up. 120 plus 80 plus, we said y was 60 plus z, which was 100. Let's make sure that this equals 360. 120 plus 80 plus 60 plus 100. 360. Yep. We did a good job. Find the values of x and y in circle C. I want you to do this now. This is just like example 3. Opposite angles equal 180 for quads in circles. Opposite angles equal 180. So circle those opposites if you need to. They have to make 180. This is M cubed, signing out.